All right, function analysis problems. The last two most recent function analysis problems were the hardest. 2019, number 3. This one was brutal. Whenever they make sure that there's fractions involved, and whenever they make things a little bit overly complicated, like they make a tough question automatically tougher. This this is a tough question. All right. So we got F. That's all we're told. This is F. We got a quarter of a circle centered at 5, 3. So quarter of a circle right there. We got this point 3, 3 minus root 5. I'll tell you a little story about what I think, why they gave us that in a second. If the integral from negative 6 to 5 of f is 7, find the integral from negative 6 to 2. It's like, what? Negative 6? It's all the way over here. Well, this is like an integral property question. We know that from negative 6 to 5, that's going to equal negative 6 to 2 to negative 2 plus negative 2 to 5. So what we need to do is find negative 2 to 5, which I can find. Then after I find negative 2 to 5, I can subtract it from negative 6 to 5 to get negative 6 to 2. So let's find the integral from negative 2 to 5. We have this area. That's triangle. Base of 1, height of 1. That's a half. This. Oh, thanks. Thanks, AP tester. This is at a half. So this base is 1.5. This height is 1. So we got 1/2, 3/2, negative 1. So this is negative 3/4. Thanks, guys. It's really nice of you for giving us this fraction. Like little things like this are starting to, will start to add up with this question. And so this next triangle here above the x-axis, we got 1.5. So 1/2 times 1.5 times 1, 2, 3. Oh, great, great. 9/4. That's great. And then we got to find this area here underneath this quarter of a circle. And it's like, how do I do that? And again, this is like why I don't like this problem. How you do that? Did you take this rectangle worth of area? Base of 3, height of 3. You get 9 is the rectangle. You subtract this area of the quarter circle. Like a lot of students actually don't know how to do this. So that's a quarter of a pi times 3 squared. So that's 1, 2, 3, 1, 2, 3. Yep. 9 minus 9/4 pi. Thanks. Thanks, guys. That's great. That's this area here. Okay, so the area from 2 to 5, negative 2 to 5, is 1/2 minus 3/4 plus 9/4 plus 9 minus 9/4 pi. Oh, that's great. That's great. Now, we've talked before, we'll say again, you can actually leave this for a no calculator free response question. If you simplify, just be careful, okay? You are allowed to place simplified calculator ready questions as your answer. 3/4 and 9/4, 6/4, negative 3/4. That's 3/2. So 3/2 plus 1/2 is 2. I got 2 plus 9 minus 9/4 pi. So that's 11 minus 9/4 pi. Okay, great. Is that what we were looking for? No. That's what the area is from negative 2 to 5. I was told that this is 7, and I'm asked to find this. So my answer is 7 minus the 11 minus 9/4 pi. Thanks, guys. That's part A. Woo! Woo! Part B is actually not a function analysis question either. Like, this is a derivative rules, part A. Part B is actually just a fundamental theorem of calculus. Can you take an antiderivative and use Mr. Newton's way to find the area under a curve, change an antiderivative? 2f of 5 plus 20 minus 2f of 3 plus 12. Okay, great. F of 5 is 0, so I just get 20 minus, and this should be in parentheses. Be careful. F of 3. You know what I think they did, honestly? I think when they first made this question, they're like, ha ha ha, let's have them try to find this. And you have to use trigonometry to find like that y coordinate. And it was so cruel. And I think somebody was like, yo, dude, make it a little bit easier, please. Give them that point. Because, like, why didn't they go from 2 to 5? That's my question. Why do they go from 2 to 5? Because then it would just be like f of 3, okay, or f of 2. That's 3. I think whoever made this wanted it to be hard, and then somebody's like, all right, rein it back a little bit, give them what f of 3 is. All right, 3 minus root 5 plus 12, and that's your answer. If you want to simplify it, congrats, have fun. 20 minus 6 minus 12, so that's 14, which is 2. So plus 2 root 5. So 2 plus 2 root 5 is the answer. Okay, finally, we get to a function analysis. This is what we know a function analysis to be. Finding maxes and mins, finding points of inflection, finding absolute maxes and mins. Okay? This is the only function analysis question in this entire function analysis looking problem. Find the absolute max of g, and g is the accumulated area from -2 to x under f. All right, well, first we got to be very comfortable with the accumulation function, whose derivative is just f of x. All right, so turns out this graph of f for part C is really just the graph of g prime. We know we can analyze signs of derivatives to then understand what my original function is doing, increasing or decreasing. Signs being positive or negative. Positive signs until -1, negative signs to a half. Again, thank you, AP testers. Positive signs till 5. That's telling me G is going up, down, up. Okay, that's it. They don't ask you about points of inflection or anything. It's just that. So where do we have a max? Well, if you are like a 3 student, you will pick -1 and you will move on because you're not correct. You'll get some partial credit. But if you're like a 4 or a 5 student, you realize that the absolute max could occur at this endpoint 5. So we have candidates. Now, to kind of invoke the candidates test, you need to start with your justification, which is that an absolute max of G occurs at a relative max. That's when G prime changes sign from positive to negative, or an endpoint. Now, we've already kind of found some stuff that we need to find some values. You should look at -2, which is the other endpoint, even though you know it's not going to be the max. But since you said it could be at an endpoint, that's technically a candidate. You'd have to say something like, oh, G prime is positive from -2 to -1, therefore G of -2 is not the max. Now that covers it, but usually when you have multiple candidates, it's just easy enough to include an endpoint. So our candidates are G of -2, and guess what? G of -2 is the integral from -2 to 2 of f of t. That's 0. That's easy. Okay, we got G of -1. G of -1 is a half. Okay, that's easy. But then we also have the endpoint G of, was it 6? 5. 5. And what was that? That was the area from -2 to 5, which was the 11 minus 9 pi over 4. Okay. Which one's biggest? Well, we know it's not 0, and we actually knew that it's not 0 from the get-go. But 1/2 and 11 minus 9 pi over 4. Again, this is why this problem was wicked tough. Like, I don't know. What's 9 pi over 4? Let's do our best to approximate. 9 times pi, that's like a little bit more than 27. Divided by 4, it's like 7. 11 minus 7, that's going to be bigger than a half, this one wins. Okay? Um, and if you just write this down, if you have your candidates, you'd say that's the max value, 11 minus 9 pi over 4 by the candidates test. Limit question. When you see a limit question, you should be thinking, oh, it's got to be L'Hopital. It's got to be L'Hopital. It's got to be L'Hopital. L'Hopital's, right? We got a L'Hopital way out of this problem. Take the derivative. Take the derivative. Hold on, guys. You got to check to make sure you get 0 over 0. This is a trick problem. Again, brutal question 1 on the AP exam. And both AB and BC students had this question. Brutal. F prime of 1 is the slope of this line segment up 2 over 1. This is 10 minus, I immediately know that it's not a L'Hopital's rule problem. 10 minus 6 is 4. What the heck is the arctangent of 1? You can actually leave this. I was told that you could leave it. I assume that you need to find it. F of 1 is this point 1. And then the arctangent of 1, what's the easiest way to find the tan inverse of 1? Well, it's like, I don't know what it is. Well, take the tangent of both sides. When does tangent equal 1 pi over 4? That's the answer. This is one of the hardest question 1s I've ever seen. Oh, question 3s. So this is like the first question of the no calculator part. Let's see how we did. 2000. Yeah, I'll even prove it to the BC students right here. 2019 BC scoring guidelines. Number 3. Yep, there it is. 9 pi over 4 minus 4. 7 minus 11 minus 9 pi over 4. Boom! Got it. 9 pi over 4 minus 4. That was worth 3 points. Oh, look at that. You get a point if you kind of understand what you need to find. The whole like A to C equals A to B plus B to C. That's nice. Finding the area from -2 to 5. Yeah, most of you wouldn't have gotten that. And then getting the answer. Part B, taking the antiderivative, plugging your values. 2 plus 2 root 5 is the final value. 2 times, oh, yeah, I got that. 2 plus 2 root 5. Okay, that was worth 2 points. This is what I did. I just took the antiderivative. I didn't split it up. Part C, I hate how they include candidates of, and they do this on the scoring guidelines. They included a candidate of a relative min. They included 1/2. It's like, we didn't have to include a 1/2. It's not a candidate. Exclude it. Absolute maxes are relative maxes are endpoints. This is stupid. We identified the candidates. We found the values. 11 minus 9 pi over 4, 1. That was 3 points. Part D was only worth 1 point, which is just plugging it in. That's a brutal problem. 2018, number 4. I literally don't have to look it up. Every single year has a function analysis for your response problem. 2018 was also a tough problem. And I believe it also was on the BC test. Number 3. Yep. Yeah, this is tricky too. There's actually controversy with this problem amongst the AP teacher community. And I'll show you in a second. Again, like A, B, another reason why this is like a tricky function analysis, it has nothing to do with function analysis. It's not maxes or mins. It's finding values. And whoo boy, if there's anything you're going to be prepared for on the free response portion of the test, it's finding an unknown value, given a known value, and a derivative. G is the derivative of F. So this is F prime. How are you going to do this? Boy, howdy, you better be ready to use unknown equals known plus the displacement, the change in our function, which is the area under our derivative. Be careful, we're going from right to left instead of left to right. This is 3 plus from from 1 to -5. Let's find -5 to 1. We'll take the opposite of all those areas. So this is 1, 2, 3, 1, 2, 3, -9. This is 1, 1, 2, 3. Thanks, guys. 3 halves, negative 3 halves. We got 0. We got 1, 1, 2. This is 1. Thank you. We just have to go to 1. That's it. 1 to 5. So I got 3. I'm going to add 9. Add 3 halves. And I'll subtract 1, doing the opposite of what I would do normally. Or just find the area and then make it the opposite. It's up to you. 12, 11 plus 3 halves is 12 and a half. Okay. I bet you that's like a 3-pointer. Part B, evaluate the integral from 1 to 6 of g. You're told what g is. G is this piece of the function. We want to find the area under it. Guess what? It's a non-calculator question. I know we don't like to do it. I know it's tedious and annoying, but Mr. Newton is our hero, so we need to be prepared to honor him by finding areas, not using our calculators, but finding the change in the antiderivative. Leave it like that. Leave it like that. Don't try to simplify anymore. You're just going to waste your time. You're probably going to make a mistake. That's the answer. All right, now we got function analysis. When is f increasing and concave up? Give a reason for your answer. All right, well, function analysis, get your number lines out. F is increasing when f prime is positive. That's going to be from 0. It'll flatten out at 4 and then to 6. I'm not even going to include the parts to the left. It's positive, 0, positive. When are we concave up? That's when our second derivative is positive. So starting at 0, let's go to 6. I'm positive until 1. These slopes are all 0 until 3. Negative from 3 to 4, my number lines are all screwed up. Negative from 3 to 4, and then positive after 4. So, increasing and concave up, 0 to 1, 4 to 6. Okay, great. 0 to 1, 4 to 6. But then they ask the question, when do we have a point of inflection? And here's the controversy. 4, the second derivative changes sign. That's our justification. Keep it simple. What's your reasoning for this? F prime is positive, F double prime is positive. Keep it simple. What's our reasoning for points of inflection? The second derivative changes sign, right? Well, at 4, the second derivative changes the sign, right? But it also changes sign like between 1 and 3. Like we go from positives to negatives. But then they ask for like a point of inflection. Isn't this like an interval of inflection? That's where the controversy is. I don't even know exactly what they wanted for the answer. But if you like included the interval 1 to 3, I think they accepted it. It was stupid question that they asked, honestly, to include that. 2017, or somebody was trying to make a point of something. Point of inflection. Let's look at how the points are distributed. Sorry. See, was it on the BC test too? Number 4, usually the function analysis is. No. Was it number 4? Or was it number 3? It was. We were doing number 3? Oh, cool. So that's it. This is it. Split at x equals 3? Why? Oh my goodness, I made a mistake on B. They looked for 1 to 6. And I was just doing 3 to 6. I only did this part. My bad. We needed the part under the 1 to 3, the rectangular part. I gotta change the calendar. This is number 3. So yeah, this is on the BC test too. Oh yeah, I was just looking at the wrong problems. Okay, so that was my bad. Part C, 0 to 1, 4 to 6. And here's what they say. They say just at 4. So they didn't include like the interval because it's not a point of inflection, it's an interval of inflection. I'm pretty sure if you included the interval, they wouldn't have worked anything off. All right, that's 2018. 2017. Let's go. All right. This is more like it in terms of free response, function analysis problems. This is number 3 in 2017. Okay, I got to find f of negative 6 and f of 5. I'm told what f of negative 2 is. They have to tell you this because they give you the graph of f prime. And guess what, my friends? This equals this plus this. How many times do we see it? We see it almost every single question we've done so far. This equals this plus this. How many times do we see it? We see it all over the place. So I need the area from negative 2 to negative 6. I need the area from negative 2 to 5. Here's negative 2. This area, 1, 2, 3, 4, 1, 2. This is 4. This is a half of a pi times 2 squared. So that's 2 pi, but make it negative. It's underneath the x-axis. 1, 2, 3, 1, 2. This area is 3. At least there's no fractions or crazy areas under circle kind of things. So this first one is going to be 7. From negative 2 to negative 6 is the opposite of negative 6 to negative 2. Minus 4, that's 3. The next one is going to be 7 minus 2 pi plus 3. 1, 2, 3, 4, 5. So that's going to be 10 minus 2 pi. All right. Cool. So we got some values. Guess what? We're going to use those values in part C. So they kind of help us out. A lot of times they will ask you to find answers in an earlier part, and you'll use them in a later part. When is f increasing? F is increasing when f prime is positive. This is the graph of f prime. This is your justification. You literally don't have to write anything beyond f prime is positive. F prime is positive from negative 6 to negative 2 and 2 to 5. Absolute min. Justify your answer. An absolute min occurs at a relative min when f prime changes sign from negative to positive, which it does right here at 2, or at an endpoint, 5 or negative 6. I have candidates. My only candidates really are negative 6 and 2. We know it's not at 5 because f goes up from 2 to 5. However, you have to say that to exclude your referencing of it. So if I'm going to be proper with my justification, I'm saying f has an absolute min at a relative min. That's when f prime changes sign from negative to positive. I'll literally write that. It's just quick. Or an endpoint. I can either state that I'm not going to look at 5 because f prime is positive from 2 to 5. But since I already found f of 5, might as well just put it down. So I got f of negative 6, which is 3. I got f of 2. I have not found f of 2. F of 2 would be 7 minus 2 pi. And then f of 5, I already found was 10 minus 2 pi. I know it's not this. This is out. I mean, I didn't have to check it, but you'd have to stay it. Sometimes it takes longer to say. Which one's smaller, 3 or 7 minus 2 pi? 2 times pi is like 6.28. 7 minus that, this one's. The absolute minimum value is 7 minus 2 pi by the candidates test. D, what's the second derivative of negative 5 and the second derivative of 3? The slope of the tangent of f prime will give us f double prime at negative 1, 2, 3, 4, 5. This tangent slope, the slope of this line segment, down to over 4. Excuse me. Negative a half. F double prime of 3. Slope of the tangent here at 3 is non-existent. Why? Sharp point. I hope that they would accept sharp point, and you don't have to look at the limit. As x approaches 3 from the left of f prime is positive, the limit as x approaches 3 from the right is negative. Therefore, the derivative doesn't exist because the limits don't equal each other. Just say it's a sharp point. Let's not stress. All right, let's look at the results. 2017 BC test. It's also on the AB test. So there's number 3. Number 3 for both tests was our friend the function analysis question. 3, 10 minus 2 pi. You got 3 points. Using the formula in your initial condition. 1 point. You gotta know this formula. You gotta use this formula. They included negative 6. I did not. They should. I should have because f prime is positive at negative 6. I wonder if they would take a point off. I don't think so. F prime is positive. That's all you need. Look at that. Look at these silly AP testers who are including negative 2. Obviously, it's not negative 2, guys. It's a relative max. And they include 5, but like part of our justification means. See, they say at a critical point or at an endpoint. We just go a little bit beyond. We said relative max or an endpoint. We found at the value f of 2, we got only 2 points. That's surprising. Usually absolute maxes and mins are 3 points or more. Yeah, look at that. They're looking at limits. Jerks. Whatever. Just say it's a sharp point. This is a little bit crazy. I don't want you to focus on it. If everybody loses the point on this, that's fine. Usually it's just like, or find the value or say if it doesn't exist instead of explain why it doesn't exist. All right, 2016. Number 3. I think this is also a BC question. All right. We finally have our friend the accumulation function. Really, we were using the accumulation function this entire time. You just didn't really realize it. I just want us to be careful. Sometimes they will put something after the accumulation function. And when that happens, everything changes. Okay? We'll talk about that towards the end or we can even do it for part A. All right. When does G have a relative min or a max? Or actually, it's like max, min, or neither at x equals 10. All right. Well, we need to analyze G prime. Got to know that the accumulation function's derivative is just f of x. F is just G prime. So at 10, G prime does not change signs. G is going to go down, flatten out, go down. It's neither. G prime does not change signs. Easy. Does the graph of G have a point of inflection at x equals 4? We need to look at G double prime. G double prime are the slopes of G prime or the slopes of F. At 4, the slopes change from positive to negative. Be careful of what you say. Don't say G prime's slopes are increasing. If you say G prime slopes, you're talking about G double prime. If you're talking about something increasing, you're talking about its derivative being positive. Just say G double prime's slopes change. Don't say increasing or decreasing. The values of G double prime change signs. Oh my god, I just said it. G double prime sign. I just messed up. G double prime signs change. G double prime slopes change, or G triple prime signs. Signs of derivative. I just said does not change signs. All right, find the absolute min and max value of G. So same deal. Like, let's expand our graph of G prime. We got -2 is a relative min. We got 6 is a relative max. And that's it. We have 4 candidates. G has an absolute max slash min. And you could say at a critical point, or how about when G prime changes signs? That means you don't have to check at 2 and 10. When G prime changes signs or at an endpoint. So I need to find, I'm going to do it up here, G of -4, G of -2, G of 6, G of 12. And these are all integrals from 2 to the value. 2 to -4. Okay, this is 4, 4, so this is 8. This is -4. This is 8. This is -8. This is -4. That's easy. 2 to -4 is the opposite of -4 to 2. -4 to 2 would be +4. This is going to be -4. Okay? This is going to be a bigger value, lesser value, because G is decreasing. G of -2, 2 to -2 would be -8. Okay? We also could have a min at 12. We'll get there. G of 6 is 2 to 6. 2 to 6 is 8. G of 12, 2 to 12 is -4. Here is my min. There is my max. They both occur at relative mins and maxes. And that's okay. When is G negative? Let's find when G is 0. When does the integral from 2 to x of f of t equal 0? Well, when x is 2, we have 0. All right. Then we increase by 8, then we decrease by 8, getting us back to 0. So I know that G of 10 is also 0. G of 2 is 0. I'm going to increase by 8 to get to 0. I won't be at 0. So really, I just get to 0 at 10, which means I'm going to be negative from 10 to 12. All right. See how we did. 2016. EC scoring guidelines. Number 3. Yep, there it is. It was on the BC and the AB test. It's neither. G prime does not change sign. Just use that. Part B. Point of inflection. G double prime changes sign. Keep it simple. Don't read this. This is 1 point. This is 1 point. You get 1 point for just writing G prime equals F somewhere. Right here, right here. Boom, I got a point there. 4 points for this absolute max and min. You got to consider the endpoints. You got to find the values. For this question, I did have to check all those values. -8 and 8. -8 and 8, we win. And 10 to 12. -4 to, oh my goodness. I increased by 8 to get to 0. G of -2 is, yeah. Oh, gosh. Soft. Yeah, I go to 0, but I'm going to increase, like, you can see all these values are negative. I start at -4. I decrease by 4. And then I add 8 to get to that point of 0 on the graph. So, man, I lost a point. Got 1 point there. 8 out of 9. All right, 2015. How many have we done? 19, 18, 17, 16. I'm going to do 2 more, and then I'm going to cancel the rest of the problems. 6 problems are enough. 2015. Oh, this one was like the easiest one in so many years. It gave you the graph of f prime. The most toughest one was like using the equation that we know how to do. It's really simple. Here's f prime. Told you the areas are 9 and 12. Okay, great. When does f have a relative max? F has a relative max and f prime changes sign from positive to negative. That's going to be at -2. That's it. X equals -2. F prime changes sign from positive to negative. Just write that out. That's it. Signs of f prime. Don't say increasing or decreasing. Don't say slopes. Signs, positive to negative. When are we both concave down and decreasing? Well, we're decreasing from -2 to 4 pretty much. When are we concave down? When the slopes of the tangents of f prime are negative slopes until -1, positive slopes until 1, negative slopes until 3, positive slopes after 3, concave down and decreasing. -2 to -1, 1 to 3. Give a reason for your answer. F prime is negative, F double prime is negative on those intervals. Find the coordinates of the points of inflection. This is so easy. We just kind of figured that out. -1, 1, and 3. What's the justification? F double prime changes sign. Finally get to something that's a little bit more complicated. Given that f of 1 is 3, write an expression for f of x that involves an integral. They're like really trying to like help you out. They're like, hey guys, can you please remember the fundamental theorem of calculus and remember that you need like an integral of f prime? They're really trying to help you out. F of x equals f of 1 plus the integral from 1 to x of f prime. You're going to have to change the variables, but whatever. I think that's what they want. And then they want f of 4. That's f of 1 plus an integral from 1 to 4 under f prime. We are told from 1 to 4, this was 12. It's underneath the x-axis. We consider it negative. So we get 3 minus 12, which is -9. F of -2 equals f of 1 plus the integral from 1 to -2 under f prime. This area is -9, but we're going from right to left, so it's the opposite. Make it a positive 9. So 3 plus 9 is 12. So I go 12, I decrease 9 to get to 3, I then decrease 12 to get to negative 9. I don't think this was on the BC test, actually. 2015, let's see. BC 2015 scoring guidelines. Hopefully this was just an AB question because it's so easy. Number 5. Yeah, you guys got a different one. Finally, the AB students got easier questions than the BC students. All right. 2015 AB scoring guidelines. There it is. Identifies x equals -2. F prime changes from positive to negative. Boom. 2 points. -2 to -1, 1 to 3. F prime is negative, F double prime is negative. 2 points. Point of inflection at -1 and 3. F double prime changes sign. Yeah, gosh, they write so much. You don't have to do that. Just say F double prime changes sign. Okay, 1 point for this integral where you have x here, and then this has to be something else. They use t, I use t. You can use whatever you want. But the key to the accumulation function is the disagreement in variables. This can't be x, and that's x. Don't think they would give you a point for that. -9, 12, using an integral. Okay, that's 2015. Let's do 2014. And then I think I call it there. 19, 18, 17, 16, 15, 14. Yeah, this is the last one. All right. Now, what I didn't mention is the following. What if this was plus 2x? Okay. What if that was plus 2x? And I asked you, when is g increasing? Everybody's going to be like, oh, I know when g is increasing. It's when our graph is above the x-axis. And they're like, -5 to 2. And maybe they exclude -3. Right? That's what we do. We look above the x-axis. It's right here. No. Be careful. And like on the free response test that you guys are going to take in my class, one of the 2 tests that I'm going to give you has a plus this. Things change. G prime is F plus 2. What does that mean? You could take this graph of F, shift it up 2, and that's what you need to look at. Or we look at when signs change, right? That's when F equals -2. Remember that, Mr. Sudovan? I stressed that last year. Okay? Now, 1, 2, 3, 4, 1, 2. So this is a slope of -2, so I'm going to go down 2 over 1. 3. G is increasing, if this was the case, from -5 to 3. We have a relative max. We'd have an absolute max at x equals 3. Fortunately, the last like 5 years, they didn't have any of that stuff. Last 6 years. But on the practice tests that we give out, and on the test that you guys took for me, we had that. Okay, so let's remember that. Don't forget that. Heads up. Everybody messes up on that. They think everything's just like the same over and over and over. It's not. All right, anyways, let's find g of 3. It's easy. Integral from -3 to 3 of f of t. -3. 1, 2, 3, 4. So that's 6. Right, 3 plus 2. 3 times 2. And then this is going to be 4. And this is 2. This is -4. Isn't it so nice when they give you whole numbers and not fractions? Why are they being such jerks recently? They used to be much nicer. -3 to 3. Oh, well, they did. They did do this to us. That is a little bit jerky. So using the slope, this crosses at -2. This ends up being -1. Base of 1, height of -2. So this is 9. When is G increasing and concave down? G is increasing when G prime is positive. G prime is positive from -5 to -3. Then it's 0. Then it's positive until 2. We'll just look there for G double prime. G double prime needs to be negative for it to be concave down. We are negative from -5 to -3. We are negative from 0 to 2. So both is -5, -3, and 0 to 2. What's the reasoning behind my answers? G prime is positive. G double prime is negative. All right, part C. Do you know your derivative rules? What's h prime of 3? Take the derivative of the top times the bottom, minus the derivative of the bottom times the top, all over the bottom squared. Plug in 3. Awesome. G prime of 3. G prime of 3. It's a good one. G prime is the same as F. F is G prime for this situation because there's nothing added to the accumulation function. So G prime of 3 is F of 3. F of 1, 2, 3 is -2. That point right there is -2. It happens to be the slope too. So that's lucky if you get it wrong. 5 times 3 is 15. Minus 5 times G of 3. G of 3 we found earlier. It's 9. Over 15 squared. Thanks, guys. You can leave your answer like this. 2 times 15, -2 times 15, 5 times 9, 15 squared. Leave it. Calculator ready. It's a non-calculator question. D, there's P. Find the slope of the tangent to the graph of P at the point where x equals -1. Yeah, it's really just like another derivative rules. What's P prime? Well, it's a chain. Outside, inside. The outside's f of, the inside is x squared minus x. So P prime is f prime of x squared minus x times quantity 2x minus 1. So P prime of -1 is f prime of -1 squared is 1, minus -1 is 2, and then -2 minus 1 is -3. F prime of 2 is the slope of the tangent to f at 2. Slope of this tangent is -2. -2 times -3 is +6. Let's see how we did. Nine. 1 point for 9. -5 to -3, 0 to 2. G prime is positive, G double prime is negative. 2 points. This 15 times -2, 5 times 9 over 15 squared. 3 points. 2 points for just writing down the derivative using the quotient rule correctly. That's a nice 2 points. 2 points for writing the derivative using the chain rule correctly. 1 point for getting your answer 6. All right, 2019-18. Really tough. Rest of the years, not so bad. I would think that this year, guys, it's going to be easier than other years. They're going to be a little bit lenient, considering. Oh, this was on the BC test too. Considering our situation. I wouldn't think there would be a 2019 type question, which was really tough.